Can you hear me in the WeChat stream? Okay now? Or still not okay? Why? I mean, why? Yeah, now can, right? Okay. Ah, I think so now. Yeah, right. So, yeah, let's start it. Okay. So let me just start from here, right? So I won't repeat some of the word I have said before. So just here, right? So now we have the k is the factor of this one. So we just want to determine so how many different factors are for this. So the number of factor of this one is 3 plus 1 times 1 plus 1. So we have 8 factors, which means we have 8 different value of k. Then we have 8 different value of x, right? So 8 different values. Question 2. So easy question. So the price is decreased by 5% and then increased by 40%. So the new price is 990 more than original. So it's something that we assume it to be 1u, then it becoming a 95% of u, then becoming 95% times a 140% of u. So now this one equal to 133% of u. So the difference is 33% of u equal to 990, then u equal to 3000. Quite easy one, right? So I will mark. So this is an easy question. This is an easy question. So question 3. So also an easy question, I have to say. So it's it's AB and then C. So AB increased by, so let me tell u. So 1300 minus u, right? So now this one increased by 25%. And this one decreased by $50. And the total is increased by 190. So then it's easy to find that 25% of u minus 50 equal to 190. So we can get u equal to 960. Then it's asking for C. So 1300 minus 930 is a 340. Yeah. We run through the easy question quickly. Okay. Yeah. Okay. Then question 4. Yeah, this is a relatively difficult question, I have to say. So maybe, right, in this question, we can list the number out to find the patterns here. So first, at start, we have 2000, not 2024. Yeah, it's 2000 numbers here. And then in the first period, so we just check, so how many square numbers are below this one? So actually, we have 44 below it. So in the first operation, we minus a 44, right? So then we reach to the, calculator. 1956. And then we should remove another 44. No. So 44 square is 13. So we minus another 44 to becoming and 19. And then we should minus the 43, right? So then we should minus the 43. So minus a 43 becoming 18. And then minus another 43 to make it into a 1826. So did you see the pattern here? Right? Did you see the pattern here? So the pattern is the minus 44, minus 44, minus 43, minus 43. Then it's a minus 42, minus 42. So the pattern always go like this way, right? The pattern always go like this way. So from 44, 43, 244, 243, and 242s. And this will repeat until, right? So because, right, we have the square difference here. So we have the square difference here. So because, right, 2000, so we have the square number, which is the 44 square. So 44 square lies here. And the 43 square lies here. And then because the 42 square lies here, right? So we can reduce it by 44, 44, 43, 43, 42, 42, right? So if we keep doing this process, right? If we keep doing this process, so it will eventually reach a minus 2, then minus 1, minus 1. But if we need to check, so 1, 2, 244 times a 2. Actually, this number is a 1890. It's smaller than 2000. So which means, right, if we only do this process, for 88 times, so it will reduce to a number of less than 2000 numbers. So how does this happen? Because, right, because during one of the process, so actually we need a 19 here. So the reason is when we keep doing this process, we will eventually move to a square number which is just on, the square number which is just on the road. So the number is the 20. The number is the 20 or the 19. So this process will keep into the square. So it will reach, so actually it will reach to a 20 square. And for this 20 square, so because it's just on the line of a square number, so we should then minus additional 20. So in this case, we move it into an 19 square. Not a 19 square. So it's 19 times 20. So this is a 380. We should move to a 380. Then start from the 380. It's 380 here. Is that 380 here? Is that 380 here? No. It's 3. No, it should be something like 381 or something. It should be the 381 or 382. 382. So actually, we should move. So the period is not it's not a Keegan set. It's not a 20 square. It's not a 20 square. So in this case, we would have an, let's calculate this. Let's calculate this out to find what's the answer. So it's 20 to 44, and then times, and so how many numbers are there? It's 25, right? Times 25. Divided by, don't divide by 2. So it's 20 square. It's 20 square. So we reach 20 square. So, and then, so we should then remove another 20 to reach a 380. So now in this case, this number is just one number less than the 19 square. So which means, in this case, we overtake the 19. We overtake the 19. And then we have the minus 2 of the 18, minus 2 of the 17, minus 2 of the 16. And then we repeat all the whole process. And we should notice that sorry. So this is a 19. This is a 19. This is a 19. So now in this case, it's 19 to reach a 3-1 square. So this is a 19 square itself. Right? So, and then, so we should move, right? Step by step. It's 20 square. Then we minus a 19 minus an 18 to reach the 18 square. So now we build another square sequence here. Right? We should build another square sequence here. And so the square sequence would continue until we reach the 4, right? Until we reach the 4. And then it continue when we reach the 2 square, then to the 1 square. sorry, 2 square, and then a 2, then a 1 square. So now we would see we can divide it into 2 periods. In the first period is that when we just reach a perfect square, which is a 20 square. And in the second period is that, so it's 20, 19, 19, 18. Then it's an 2 to 1. So we see that from one square to another square, we should move 2 steps. So totally, how many steps are there? So the first period, we have 25 times 2. We have 50 steps. Okay? And then in the second period, it's 20 to 1. We have 19 times 2. We have 38 steps. So totally, we have 50 plus 38. So sorry for that. It's not 87. It's 88. So we have 88 steps to reach the final goal. This is a very difficult question, but it's easier than I thought. So I just treat it as a regional question. Do you know what the original question is? The original question is, so what is the initial number for the last? So we know there is only one last, right? Only one last. But the question is, so who is this last? So who is this remaining? So do you know how to solve this question? So who is this remaining one? So the remaining number should be 81. The remaining number is 81. Sorry, it's 1981. So the logic is that, so the original question is, if we trace, if we trace the remaining numbers position, you would see. So it's 1, 2, right? So if we have 2s, then it's a 2. So then if we have 4s, the number is in number 3. And then becoming number 5. Then becoming number 7. Then becoming number, so this 2, this 3, number 10. So this is we can trace the remaining number. We can trace the last remaining one. So we trace it order back and back and back. So, and then we would eventually see, this follows a pattern is that it's plus 1, plus 1, plus 2, plus 2, plus 3, plus 3. So actually we have 88 steps to go, right? So the final remaining is 1 plus this 1, 2, 44, then times the 2. So this is the way we get the final remaining answer. Yeah. But never mind, so this question is much easier. So just ask the time. So you just find the pattern and you will know how to do it. So you can just maybe list all the number up to get the answer. Or you can trace from 1 to 4 and to get the answer. You trace it back. It's also okay, right? So, but never mind. Yeah, this is the question. And then for question 5, right? For question 5. So question 5 is something called the plate insertion. So if you are a long-term course student like Rishan, right? So I just talk about plate insertion for nearly a whole class. This is very important. So you see, so for all the questions I collected here, there are 2 questions that are about plate insertion. So it says that we have 8 identical dice and they have 6 different points, 1 to 6. So it's 8 identical balls into 6 distinct values. So because we can have 1 point with no, right? So each can be 0. So very classic plate insertion problem, right? So it's quite easy because, right? So first, we have initially we have 8 identical dice, but because all the 6 points, 1 to 6, they can all be 0, right? So we land them a 6, right? We make them all into 1, right? All into at least 1. So it's 14, then minus a 1. So it's actually the 14 identical dice into 6 points. So each it has at least 1. And so in this case, 14 dice have 13 intervals. we want to divide it into 6 distinct points, divide into 6 distinct piles. We need 5 places to insert inside. So the answer should be 13 C5. So it's 1, 2, 8, 7. A very typical and easy plate insertion, right? So you just treat it as identical balls into distinct boxes. So I believe in my class, I taught about questions much more difficult. So do you remember the plate and dish problem? Yeah, sorry, yeah, the plate and dish problem, right? So sometimes I have 4 plates for the 20 dishes, and I can choose not to choose to fulfill all of my plates. Yeah, that question is more difficult than this one. So yeah, this should be though it's a question 30, this normal one. Yeah, I name it a normal one because it's not that easy. Yeah, it's not that easy, but it's not difficult. Okay, then move to question 6. So question 6 is something like, so when a number is divided by 100, quotient is Q and the remainder is R. So now, if a number, a 4-digit number, so we just treat it as A, B, C, D. So now A, B, C, D divides by 100. So actually, the quotient would always be this AB. And the remainder would always be this CD. And while we can have AB plus CD equal to a multiple of 11. So which is, so this is 11 divides this one, right? 11 divides this one. So now how to make use of this one? 11 divides this one. So actually, if you see this, this is the, yeah, don't worry about order. So this order is from when I received the question, not the actual order of this question. Okay. So now, yeah, we know if we divide the number into 2 and then add in their sum, so it's a characteristic of 11 and 99. So if 11 divide AB plus CD, so we can get 11 should also divide this ABCD. Right? So we should notice that 11. So ABCD actually is a multiple of 11. Okay with that. So any multiple of 11 should satisfy this. But however, so the question, so I don't know the actual question actually, but yeah, I have to say that if we say that this have a remainder, so the remainder must not be 0. Or maybe might not be 0 because I don't see the real question. So did the question says that this cannot be 0? I don't know. Did the question say about this? I don't know. I don't know. So maybe yes or maybe not. But never mind. So we just treat it as it cannot be 0, which means, right, as long as A, B, C, D is multiple of 11, it's okay. But we can make CD not 0. So which means, so the A, B, C, D is a multiple of 11, but CD is not 0. So CD not 0, so not a multiple of 100. So then, right, so we just calculate how many A, B, C, D are there. So first, how many multiple of 11s are there? So maybe 1000 divided by 11 is some 90 remainder 10. 9999 divided by 11 is the 909 remainder 0. So the multiple of 11 range from 11 times 91 to 11 times 909. So how many numbers are there? So it's 909 minus 91 plus a 1, right? So there are A99, but yeah, sorry, A19. But still, we should notice that we should remove the 1100, 2200, 3300, right? We have 9 number, which is a multiple of 9. So minus a 9. So the answer is 810. So if it can be 0, we just add in this 9 back. So if R can be 0. I don't know. So normally when we talk about we have a remainder, the remainder is not a 0, right? So if it can be 0, just add in this 9 back. Okay. So And then for question 7, so question 7 is something that, so we just find that, so this 3p squared q, 2pq squared. So we have a pq here, right? Yeah, it's pq here. So which means we can take the pq out. So the pq times 3p plus 2q equal to 4a3. So we just do the prime factorization. Yeah, so this one is normal or difficult? Normal or difficult? So maybe difficult one. Yeah, I treat it as difficult one because it's not easy to think of this way, right? So maybe I treat it a difficult one. Yeah, okay. For question 7, right? So we just make it this way and then you do the prime factorization here. So it's 7, 3, and 23. So now we just set the value of p and q, right? So I don't know if there is this sentence. If pq are prime number, right? So if pq are prime number, there is only one solution, then p equal to 3, q equal to 7. This is the only answer. But if then there is no maximum value, something like that, right? But anyway, so if pq are prime, so only p equal to 3, q equal to 7. So if p and q are not necessarily prime number, there is another answer, which is the p equal to 1, and then, sorry, it's q to equal 1 or p equal to 1. Let me check. Yeah, I believe there is another answer. So with 1 being a 1 or something like that. Yeah, but never mind. So there is, yeah, then never mind, right? So the answer is 10. The only solution is 3 plus 7 is a 10. And this is the only answer. No other ways. Okay, this is an easy one. Yeah, treat it as an easy one. If with prime number, it's an easy one because there's only one solution here. But if we don't have this word, it may be complicated, I have to say. Right? Okay, so then question 8. So question 8 is something like the Pythagorean theorem in a circle. So this is an arc. It is a circle, so maybe we just find the center of the circle, which should be here. Then we connect it. So because C is the midpoint, right? So in a circle, the midpoint of a chord is always perpendicular to the radius. So this is, or you can just use the, right, associated triangle heuristic to prove it. So now this is perpendicular. So this is the R. So OA is the R. OD is the R. So OC is the R minus 1. So in this right angle triangle, we would see that it's 5 squared plus R minus 1 squared equal to R squared. So it's 5, 12, and 13. So R equal to 13. It's something for the diameter. Then it's 2 times 13. Then it's a 26. Easy question. Yeah. Okay, we skip easy question quickly. Question 9. Maybe normal question. Maybe normal questions. So from 1 to 2024, so how many numbers are there where sum of its digits equal to 10? So first, about multi-digit number, we first should discuss, so how many digits are there, right? So one-digit number cannot, so maybe starting from two-digit number. So a two-digit number, so we just have 19 to 91, so we have 9 options. For three-digit number, so it's the A, B, C, where A plus B plus C equal to 10. Then again, we can use the plate insertion method, right? So then we can use the plate insertion method. So because we have a sum of this number equal to 10, and so A is at least 1, but B and C, they can all be 0. So now the plate insertion is first, we land 2 for B and C. And then we divide the 12 into 3, with each of them should be at least 1. So we have 11 intervals to plug in 2 plates. So the answer would be 11 choose 2. It's a 55. But notice the very important thing. This 55 must minus 1 to be the 54. Why is that? Because in this case, we assume, right, so A, B, C, sum is 10. So there is one case that we distributed into an 10, 0, 0. So we could have a 10, 0, 0 here. So which is not specified. It's not a 3-digit number. So we should remove this 10, 0, 0. So only 54 here. And then for 4-digit numbers, so it's the A, B, C, D, but A is smaller than 2024. So maybe we start with 1 A, B, C. So in this case, A plus B plus C equal to 9 instead. And A, B, C all can be 0. So then again, we lend 3 to all the A, B, C, then minus 1. Also a 55. And if we start with 2, maybe we just enumerate, right? So if we start with 2, so it's 2008. Then 2017. Then again, it's 2026. So only 2. So we have 9, 54, 55, 2. So totally, we have, what's the value? 33, so 65, 120. Yeah, 120. Right? So I treat it as normal, right? I treat it as a normal. Okay. Then move on. Question 10. Very easy question, right? As long as we see the mean, the average. I have a question. Do you know what's the mean meaning? Do you know the word mean? Mean means the average. So this is an American way to express the mean, the average, right? So I don't know why they use the American English instead of English, but never mind, right? The British English, right? So now, so if we see the average, we see the mean, we also lead to the total. So then we have the A plus B plus C actually is 300. And A, B, C, D, E should be 90 times 5 is 450. So we find the difference, we have the D plus E equal to 150. And because E equal to 4D, then E equal to 120, D equal to 30. Yeah, quite easy, quite easy. Yeah. In the test, they say average. Yeah, then it's okay, then it's okay. Yeah, the question said average, then it's okay. So maybe just the kids tell me with the word mean. Yeah, so because this is American English, so it's not a British English. Okay, but never mind, so we understand then so, right? So question 11, I treated it a normal one. It's not difficult, but it's about the enumeration, so it's easy to make mistakes, actually. So actually, we want to find the triangle, so the perimeter is 15, and the sides are integers. So it just want to make 15 into the sum of 3 numbers, A, B, C, and do the enumeration. So notice that there are 2 things. So first, we can assume A is no larger than B, B is no larger than C. Secondly, the sum of the 2 smaller sides should be larger than the third one. So we just use this, right? We just use this to make the enumeration. So now we can have, right, start with A, the smallest, A equal to 1. So now there is an easier way for you to do this, because instead of using the sum of the 2 larger than the 3, so we can use this. Another one is C minus B is smaller than A. This is quite easier for us to find all the answers, because if A equal to 1, then C minus B is smaller than 1, so can only be 0. So the only way is C equal to B, so which is the 7 and 7. Right, the first case. The second case is A equal to 2. Then in this case, C minus B can be 0 or 1. But if C equal to B, there are no integers, so C equal to 1. And in this case, is 6 and 7. And if 3, then C minus B equal to 0, 1, and 2. But 1 is not an integer, so C minus equal to 0, then it's a 3, 6, 6. 2 is a 3, 5, 7. And then if A equal to 4, then maybe just start with 4, 4, 6, and 4, sorry, not 4, 4, 6. It's 4, 4, 7, and 4, 5, 6. So ensure that A is smaller than B, B is smaller than C. And then 5, 5, 5. Then end of 3. So 1, 2, 3, 4, 5, 6, 7. We have 7 options here. Okay. Question 12. Right, question 12 is a very easy column puzzle. Right, just write it here. SMOPS APMO, yeah, sorry, PS is 808182. So the key point to solve this question is to use the parity, the odd and the even, right? To use the odd and even to satisfy the carryovers. So first, s plus s is a 2. So it's 2 or 12. Check this. So p and p, so itself is an even, and 8 is an even. So there should be no carryovers, right? So we use the parity for carryovers. Use the parity for carryovers. So it's 0 here. Then here you see O plus O is a 1. So O plus O should be an even number. But here 1 is an odd number. So which means there should be a carryover 1. It's APMOS. Yeah, never mind this. Yeah, never mind the question. The question may be something. Right. But never mind. Right. So this one should have a carryover. So then again, m plus m equal to 8, so there is no carryover here. S plus p equal to 0, there must be a carryover here, right? So now we can determine the carryovers, and then use the carryover, we just determine the digit by digit to get every number. So first, s plus s equal to 2 with no carryover, then s equal to 1. P plus p is 18, so p equal to 9. So now we get the 1 and 9 here, so here have no carryovers, right? And then, so it's O plus 1 equal to 1, and O equal to 0. And then m plus m equal to 8, with no carryover, then m is a 4. Then back to the A is the 7. Right? So quite easy. So the sum of this number is 10 and 11, 21. Yeah, it's APMOS, right? So yeah, I just treat yours, right? APMOS. But never mind. So the question may differ because it's just by the memory of students, right? Okay. Question 13 is easy. This is a Nemo's type question. So I believe last year's Nemo's have exactly the same question like this. So the key point is we see the 120, we see it's 180 minus 60. So we just extend the lines. So we have several equilateral triangle here, right? So we would have several equilateral triangle here. So this large triangle is equilateral, and each of the side is equilateral. So it's 4 and 4. And we don't know this one may be named as x, and this one may be named as y, right? So now in this case, because the large triangle is equilateral, so all the side lengths is equal. So the side length is 24 plus 20 plus 4 for this side. And for this side is 4x, y. And then for this side is 24, 18, x. So we can get the value of x and y out. Or maybe we can directly use the x plus y because we only ask the perimeter, right? We can just directly do x plus y, but it's also okay. Yeah, but never mind. So the x here, the y here must be 38, and the x here. So what's the x here? So x here is the 24, is the 6, right? Yeah. Okay then. So the perimeter is 20, 24, 18, 4, 6. 38. So it's 110. Yeah, easy question. Okay. Then question 14. So it says that two farmers, maybe farmer A and farmer B, they have a number of X. They have a price of X, right? So now, maybe we assume the number of x is x and y, and the price is m and n. So first, we know the total is what? So the total is xm and ny. So because they sell the same amount of money, which means we have the xm equal to yn. So this is the first thing we need to know. And the second thing is that it says, if they exchange the number, right? If they exchange the number, they will sell at a different price. So A said, if I had the egg, amount of egg you had, so which means if he used the y egg to sell at price m, so ym would equal to 270. And also, right, if B sells the X egg with the price n, so Xn is only 120. So how do we get the X and Y? So the first thing is, we just times these two together. So together will lead to a X, Y, M, N is 270 times 120. But also we know what? We know this XY equal to MN. So which means this one can be treated as XM squared or YN squared. So now this one we can just calculate this. So this is 3 to the power of 3 times a 10. And maybe just a 10, right, to be easy. So the 2 to the power of 2 times 3 times a 10. So which makes it into an 2 squared, 3 to the power of 4, and 10 to the power of 2. Yeah, this is not a prime factorization, but make it easier. So X, and then the Xm and Yn then would equal to the 2 times 3 squared times 10, which is 180. Right? So now we get the Xm and Yn, they equal to 180. Then how do we do? Then we compare with it. So we know the Xm is 180, Ym is 270. So we can get this Xm over Ym is 180 over 270. So this is 2 over 3. So this one is just equal to the X over Y. So the ratio of X to Y is 2 to 3. Then the sum of them, so the 3u, 2u, the sum of them is 400 here, right? 400 here. So the X will equal to 400 times 2 over 3 plus 2. So this is what? 160? Yeah, 160. So how should I put this one? A normal one. Yeah, a normal one maybe. Right, I treat it as a normal one. Yeah, so Lucas have another question? Yeah, I recall this question. So let's see if I have this question here. So if not, so I will add it in. So Turner? Yeah, so how can I copy the... Yeah, maybe I just screenshot your questions, right? Can ask teacher Turner to put it in, right? Okay. Meanwhile, we continue. Right? So, yeah. Question 15. Yeah, this is difficult or normal? I don't know. So maybe a difficult question. Yeah, maybe a difficult question because the logic is a little bit complicated. So it says that how many rectangles include the shaded square and the area is even. So if don't contain this word, the area is even, then it's much easier, right? It's much easier. But we can, right, actually solve the questions with, so you see, so first, this is A, right? So the first question is, so how many of the rectangles contain this A? How many rectangles contain this A? So this is very easy. So it's the logic is the top, down, left, right. So we choose one line from the top, which have 4. We choose one line from the above, which is also 4. Then we choose from left and right. So it's 4, 4, 4, 4. So it's 256, right? So we have 256 rectangles containing this A. And then secondly, so we want to define how many of them have the area is even. Even is not that easy to define because it's either the length or width is an even number, then it's okay. However, odd is much easier for us to calculate because if we want to make area equal to odd, then both the length and the width must be what? So must be an odd number, right? Area equal to odd means length and width are all odd. So now in this case, right? Now in this case, the key point is how to make it odd. So first, the logic is, so for the top, then again, we choose a random lines, a random top here. We have 4 choices. And then, so we see about the bottom, right? Top and bottom determine the width. And from the bottom here, we have 4 lines. And the distance is 1, 2, 3, and 4. Which means, for all these 4 lines, there must be 2 odd, 2 odd, and 2 even. So 2 of this line must make the distance odd. 2 of these lines must make this distance even. So as long as we determine the top 4, the bottom, we have 2 choices to make the width odd. And the same reason is for the length. So left, we have 4 choices here. And right, again, right, 2 odd and 2 even. Then times another 2 for the right. So for odd here, so we have 16 and 4. So we have 64 with area odd. Because even is hard to calculate because it can either side be even, but odd must be 2 sides all be odd. So odd is easier to calculate. And then we just use total minus extra. So with 256 minus the 64 to reach a 192. So this 192 is the answer. Right, it's the answer. So the answer is 192. Yeah, okay? Yeah, it's a difficult question. Yeah, it's a difficult question. 16. This is a GEP question, I have to say, right? Can we just skip it, right? Actually, for the first triangle, we have a 3. Then for each of the new triangles, plus 2, plus 2, plus 2, right? A GEP question, right? So then we just use the 51 minus the initial 3 divided by 2, then plus a 1. There will be okay. So the final answer is 25. Yeah. Or can we skip it? Question 17. Easy question? Yeah. That's supposed to be easy question. Yeah, no. So I haven't seen all the questions starting here. So this is the last question I have ever seen before. So now, from now on, so I will be the first time to see the question because, yeah, when the teacher turned to collect all the questions, he gave me the version until question 17. So I don't know the remaining questions. So I will do all the questions like you. So you may need to give me some more time. So if this increased by 5, increase by 5, and then this is the increasing area. But how to identify the increasing area? We just cut into 3 piles. So this is a 5 times 5. So this is a 5 times A. This is 5 times B. So it's quite obvious. The area difference is 5A plus 5B plus 5 squared equal to 200. Then we can get 5A plus 5B is M 175. Then A plus B is an 35. It's asking for the perimeter. So perimeter is just the 2 of the A and B. So it's 2 times 35 is 17. Quite easy, right? Okay. This one? Is the question correct? So question 18. Is the question correct? I don't know. So if the question is correct, then it's an easy question. But I don't know if the question differs because it's so easy. It's too easy for this question. The sum of interior angle of an n-sided figure is smaller than 124. So the maximum value of n is question correct. That's 3. Yes, correct, right? So then it's so easy, right? Because the sum of interior angles so is 180 times a minus 2, so it's smaller than 2024. So n minus 2 is smaller than 2024 over 118 is 11 something, right? It's 11 something, 11 and something. I don't know. Yeah, right. So then n minus 2 is x maximum 11. So n maximum is 13. So easy. So easy. Question 19 is difficult. Yeah, mark it difficult. So yeah. I just understand correctly. So it's n over 14 minus n is a square of an integer. So n should be an integer, I suppose. Right? N is supposed to be an integer. Or whole number. So is n an integer or whole number? Or positive integer? But never mind. So maybe we treat it as positive, maybe integer. Right. So just treat it as an integer. Okay. So now it says that, so this one is a square of number. So how to transform this one into something like that? So it's n over 40 minus n, right? We make it into this way. It's n minus 40, then plus a 40. So now because n minus 40 or 40 minus n is minus 1, so it's 40 minus n, then minus 1. So make it into this way. So now we would see, so this part, this one is a factor, because it's 40 minus over integer, so this is a factor of 40. This one is factor of 40, which means, so it can be 1, 2, no, not 3, sorry, 4, 5, 8, 10, 20, 40. So the factor of 40 minus 1 is a square number. So who can satisfy? This one can satisfy, right? So this one can satisfy because minus 1 is a 0 and a 1. So this one is a 4. And this one is a 9. So actually, we have 4 different values of 4 values here. 0, 1, 4, 9. So which makes this m being, so in this case, this one m being n, so this one equal to 40, so n being 0, m being 20, this one m being 32, this one m being 36. So actually we have 4, right? We have 4 values here, but I don't know if 0 is counted. But yeah, so if 0 is counted, then it's 4, but it's 3 if 0 is not counted. Okay, so I don't know. N cannot be 40, but n can be 0. N is 0. Yeah, n is 0. Yeah. Of course, n cannot be 40. It's 40 minus n equal to 40, I mean. Right, the value of n. Yeah. So I don't know. I don't know if you can use D0. I don't know the original question, so never mind, forgive it. Right, question 20. Yeah, question 20. So is the, yeah, I see question, so it's so long. Pyramid-like formation, so whose square base for each orange above the first level rest in the pocket formed by 4 orange in the each orange above the first level rest. The stock is completed by a single orange in the 7th level. I know what's the meaning of this question. So actually, it's the 1 square, 2 square, 3 square to 7 square. Is this the answer? Yeah, it's so long, right? The sum of the square numbers because it's the first layer, the second layer, and the 7th layer, right? I don't know if I understand the question correctly. My English is bad. But yeah, I believe it's this one, right? So then this equal to 1/6 times 7 times 8 times 15, right? So the answer is 140. If it, then it's easy. Yeah, if it isn't, then it's right. So the from rectangle solid, find the total number of different rectangular solid that can be formed this way. Yeah, so this is something like, right, A times B times C equal to 30. And we should enumerate, so how many different values for A, B, C's are there? So something like that, right? So maybe it's something about enumeration. So enumeration, let's put it a normal because it's easy to make mistakes. So we start from the smallest A, B, and C. So we treat A smaller than B, smaller than C, right? So then it's 1, 1, 30, 1, 2, 15, 1, 3, 10, 1, 5, 6. Yeah, stop here. And then start with n equal to 2. And it's 2, 3, 5. If there is no ones, so it's 1, 2, 3, 4, 5. Actually, we have 5 options. Only 5? Only 5? Yeah. So then maybe not a normal, maybe an easy. Number is too small. So for enumeration, if the number is so small, then it's okay. Then it's okay. Right? Okay. So question 22. So what's the question? So a circus has an with front and of different sides. So the diameter of the front wheel and the diameter of the diameter of the back wheel is 90. So how many centimeters did the bike advance when the rear made 10 more? So what's the meaning of this? So revolution? Yeah, maybe that's wrong. Maybe just make 10 more wrong. Maybe just make 10 more wrong. So the key point for this is the distance traveled by both the front and rear is the same. Then, which means the length, the perimeter of the circle, the ratio of the perimeter or the circumsphere of the front to the rear would be equal to the inverse ratio of their number of circle they rotate, right? So the number of circle which R, and maybe not R, so maybe it's the number of circle. So we know the perimeter is the diameter is 140 to 90. So which means the perimeter, right? So the ratio of their perimeter is 14 to 9, which means the number of circle they rotate is 9 and 14, right? So yeah, maybe I here. So the number of round, of whole round they rotate. Okay, so it's 9 to 40. So it says that if the rear wheel makes 10 more rounds, so which means if they differ by 10, then 5u equal to 10, then u equal to 2. So now in this case, so how many centimeters did the bike advance? So it's the total distance traveled. So u equal to 6. So the rear, right? The rear rotate for 18 rounds. So for the rear. And then we just times the circumsphere of this rear wheel. So which is the 90 times the 22/7, right? So yeah, sorry, this is the front wheel. This is the front wheel. This is the front. So I just put it at yeah, sorry. Yeah, I put it wrong. So this is 14. This is 9. Yeah, because so this is 140. Yeah, if I use the front. So this is the front. This is the front, right? So now this is the answer 1 and 22440. So it's right. Normal? Yeah, treat it as normal. That's normal. Right. Okay. So question 23. The question 23 is something like A, B, C be three distinct positive integers whose product A, B, C is equal to 2024. So A times B times C is 2024. So the smallest value of the sum of A plus B plus C. So actually, there is a logic. So if several numbers have a constant product, so it's the difference, as the difference is smaller, then the sum is smaller. So actually, if we want to make the sum the smallest, we should make these numbers as close as, to make it as close as possible, right? So now, first, 224 can be written into 2 to the power of 3 times 11 times 23. So how to make them close enough? How to make them close enough? Actually, we have two ways. So first, the 23 must be here, right? So then maybe we have 8 and 11. So this is one way. Or we can make it into 4, 22, and 23. So yeah, just make the number close. Make the number close. So maybe we compare with this two. So the sum of this is 19, 42. And the sum of this is obviously larger than 42. Maybe not 49. Right? This is the smallest. So it's 42. Easy question? Yeah, easy question. Easy question. Right. Easy question? Okay. So now, end of my questions. So I found the Lucas question. So how can I write? So Lucas question. So yeah, Turner send it to me. So sorry, I will just I just flagged my questions. So Turner, please. Yeah, sorry. So if you have another question, send to my WeChat. It's easier for me to get the answers. Yeah. Okay. So maybe I pause the screen share because I need to open my WeChat to get the questions. Yeah. Okay. So save and then we make it into. Yeah, so how do I put this question into the note? So yeah, wait me for a while. I'm just trying to see. Yeah. So send to. So how did I share this question with my notability and adding to the current note? Yes. Yes. And then for this one, it's the same. We add into my notability, add into current note. Yeah, let's see, can we find it here? Yeah, it's here, but a little bit small. A little bit small. A little bit small. I can drag it larger. Yeah, never mind. Okay. So, can you see now? Yeah, so the 77 kilogram, right? So the first, while if both are checked in together, so they pay. So there should be some missing. Yeah, sorry. So there should be, okay. Okay. I know, right? So I know. So maybe, right? So maybe I understand the question. So there is an maximum back weight. So below that maximum back weight, you don't need to pay. You should pay the actual weight. So you should pay the extra weight for the extra. So for the extras. I think I'm spelling nonsense. So maybe we have A being the X plus A. So this is the extra. And B is X plus B. So we should know that So they pay for $14 and $20. So it's 7 to 10. So we named this one to be x plus 7u. This one is x plus 10u. So altogether, they have x plus, so 94. So this is 47u, right? So just the extra weight referring to the price they paid, right? So we just use the s here. And we should know that because a plus b equal to together, so 2x plus 17u equal to x plus 47u, which will get x equal to 70u, right? If x equals 70u, then this one is a 77u is equal to 77 kilogram, then u equal to 1, then x equal to 30. So the answer is 30. Easy question? Yeah, easy question, right? So it don't ask for the extra price. The price is not that important. Right. Okay, question 24. What about 25? Where's 25? 25 is here. One person wants to buy 4 donuts from the shop. So 3 flavors. So 3 flavors. So how many possible combinations? Another plate insertion? Another plate insertion. But in this case, this is an easy question. It's an easy question of its kind. Actually, I turn on send to my, yeah, never mind. Okay, so this is another plate insertion. So which means, so 4 donuts from a shop. So we just want to distribute, right? So 4 donuts, 4 identical donuts into 3 distinct flavors. And each flavor can be 0. So now in this case is, so first we add in 3 for the 3 all can be zeros. And then we may treat that as 7 into 3 or at least 1. So it's -1, 3 minus 1, right? So this is and 6 and 62, which is 15. Easy question, right? Easy question. Yeah. Okay. So. Yeah, I have another question. So yeah, sorry. Okay, again, I'll try to move this question to my file. Yeah, it's here. It's here. Okay, let's see. Yeah, where is it? Where is it? Yeah, here. Yeah, maybe put in here. What is the maximum number such that if you roll a dice, the product of 5 faces showing is divisible by the number all the time? So it says that, right? So it says that no matter, right? So no matter how you roll the dice, right? No matter how you roll the dice, so it's always the product of the 5 faces because of the 1 face down. So actually, this is just asking for the normal question here. So this is just the HCF of the 1, 2, 3, 4, 5. 1, 2, 3, 5, 6. And then maybe to the 2, 3, 4, 5, 6. Right? So it's something like this. So now let's check. So how to determine the HCF of those 6 numbers? You don't need to calculate it 1 by 1 because it's too complicated, right? It's too complicated. But, right? However, we can make it easier by just define. So this is, sorry, the HCF is this HCF, not the LCM. So maybe because the HCF is something containing 2, containing 3, containing 5s. So we just discuss at most how many 2s and 3s and 5s can there be. So first, for 5, we cannot contain a 5 for HCF because we have a 1, 2, 3, 4, 6. We have no 5s. So 5 to the power of 0. And for 3, so totally we have 3 and 6. We have 2 3s. But we can remove a 3 or remove a 6. So at most, only 1 3 for all the numbers. And for the 2s, right? Totally we have 2, 4, 6. We have 4 2s. But as long as we remove the 4, so there are only 2 2s. So actually, we define the exponent of the prime number, which will be much easier, right? So because we cannot have a 5, because if we remove 5, if we remove 3, so there is only 1 3. So if we remove 4, there is only 2 2s. So the answer is 12. Yeah, okay? Okay, so now we have 26 questions. So do you recall any extra question? Yeah, do you recall any extra questions? So we can wait here. Yeah, I see Rishan's question. So it's a Monday of year X plus 1 of Saturday. What's the first year of? I write down this question here maybe. So I don't know if this question is correct. So it says that, so the 49th day of year X is Monday. And the 94th day of year X plus 1, it's a Saturday. So what is the first day of year X minus 1? Is this question? Do you recall this question? Right? So yeah, it's a little bit weird. It's a bit weird. But yeah, but never mind. So now we would see that, so the 49th day of the year X, so it's Monday, which means, right? So we can, the 49th day of year X should be the Monday. Then when we move forward for the year X plus 1, right? Move forward to the X plus 1. So maybe we just move to the 49th day of the X plus 1. So, and then, so we move to the 94th day of the X minus 1, right? Sorry, the X plus 1. So maybe we just first treated this. So 49th to, so this is the whole year. So we should plus and 365. And it has a remainder 1 divided by 7. So we should spend for 1 extra days, right? So we should spend for 1 extra days. But however, so, and then, so from 49 to 94, so we have what? 44? Yeah, sorry, 55. Yeah, 45. Yeah. So then plus a 45, which means we have a plus 3 in the remainder by 7. Right. So now we would see that from here, we can see that if this is a Monday, then Monday after 4 days should be a Friday. But instead, it says this is a Saturday. So how to make this happen to becoming a Saturday? Yeah. So this one is constant. So it's only work for this one. So this must be an 366, right? It's not a normal year. It's not a normal year, right? Okay, I see reason. I see your question. So maybe, yeah. So maybe I run through it later after this one. Okay. So the key point is this sentence tells us this year X is an, sorry, no battery. Yeah. So now this X is not a normal day. So which ensures that the year X minus 1 is a normal day. So which means if we trace it back, right? We trace it back, right? We want to get the first day of year X minus 1. But instead, maybe we first get to we just spend the whole year, right? So then we just spend the whole year here. So we first get to the 49th of the year, x minus 1. So now it's minus 365 and minus 1. So this day would be an Sunday. And then we move to the first day of x minus 1. So it's minus 48 is something like minus 6. So spend 6 days before, so it will be Monday again, right? So the answer is Monday. Yeah, so the answer is Monday. Okay, so okay, Turner, have you finished the Rishan's another question? Yeah, meanwhile, I can just put this into a picture. No, maybe I run through the Rishan question first. So n is an integer, right? So I write it here, maybe, right? So it's 2024 divides m times m plus 1 times m plus 2. Right? So now to judge, so what is the smallest value of n or smallest value of m? Right? So, yeah, so it's judged by n or m. But it's all okay, right? So, right. So find the smallest m. Right? So, yeah. So the key point is, right, for this question, so 2024, again, is 2 and 11 and 23. So the 2 is easy to satisfy, right? 2 is easy to satisfy. So maybe we just want to satisfy this 23 and 11. So we should find two adjacent number that is a multiple of 23 and 11. So if it's 23, then it should be 23, 22, and 24. I believe this one satisfies. Right, so this one satisfies, right? So the smallest m also is m. So the m minimum is 22. Then the m minimum is, if we just m minimum, so 8 here is 8 extra 3, so it's 6, right? So I don't know it's asking for n or m. It's n, right? It's asking for n, then n. Okay, 2 more questions we needed. We need 2 more questions. Do you recall any else questions? Any question else? So Turner, when you record the question, can you remove the such that out? So why I see the question you put in the system, I see the such that. Two passengers went on board on a plane. So what should the question be like? So the journey problem? Yeah, maybe we just wait here. So yeah, you can just record the questions, but meanwhile, so let us go through all the questions we run through here that was asked. Yeah, I will scroll it up to see if I see the question. Donuts? Yeah, I've run through these donuts. Donuts question done. Any other question? No, not in the chat box, I have to say. Did I miss any question in the chat box? Yeah, this discount question runs through already. Yeah. The two passenger 77, we run through it already. The passenger question, yeah, run through it already. Yeah. So no missing questions. Yeah, okay. So now, meanwhile, we treated an easy question. Okay with that? And we treated an easy question. Okay, so now let's check how many easy and how many normals are there. how many easies and how many normals are there? Let me have a look. So easy for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 of the easy questions. How many difficult questions are there? So 1, 2, 3, 4, 4 difficult questions. Maybe we treat it as a 5 because we have a question missing, right? Maybe treat it as 6. So the other are the normal questions. So it's an 6. Yeah, maybe. Yeah, this is maybe like this ratio. Maybe like this ratio. 3 to 1 to 1. Yeah, quite close. Quite close. Right? So now, yeah, maybe we do the estimation here. So for easy questions, you get an 80% correction rate. And for the my network stopped. Did my network stop? So can you hear me now? Can you hear me now? Hello? I believe my network stopped. Okay, yeah, I think I'm back. I think I'm back at least, right? So you have an 80% rate in the easy question, and we have an 60% rate for normal question, but we only have a 20% rate in the difficult question. So let's see how, so what's the score we will get? So it's 80, 20, 60. So yeah, let me calculate it. So the score should be like, calculator. So the score is, so now in this case, the score is 96. Okay, treat this as the gold line. Treat this as a gold line. Treat it as a gold line. So the gold line is 96. And then for platinum, right? Then we plus and 15. So it's 110 to be the platinum, maybe. Yeah, maybe platinum to be 110 because we just so estimate gold line 96, platinum 110. It's just by estimation. It's just by estimation, I have to mention. So I just calculate the easy question, difficult question, and normal questions, and just the times a scoring rate to get the, right, like this. Okay? So yeah, most of you, yeah, I see Lucas, I see Rishan, right? I see Keegan, right? You all have our IMO round 2 tomorrow. So have a rest. Yeah, have a good rest. So maybe I will wait here for maybe another 10 minutes. Yeah, to see if we have extra questions. If not, but I think it's not. We have 28 questions. Right? We have all 28 questions. So yeah, this is the estimated goal line and platinum line. Okay. Okay, I will log in for the WeChat channel to see if there is any subscribe. Why is that? Oh no, why is that? What is this bug? I cannot log in the WeChat channel. 21 question enough to get a platinum. 21, if you based on this. slightly not enough. Slightly not enough. But I think maybe enough. Maybe enough. Maybe enough. So Turner, are you in the WeChat stream? I cannot see the WeChat, so there's some bug inside. So any comment in the WeChat groups I need to reply? So if so, you can send me. If not, then okay. No, then okay. So now, yeah, have a good rest. Yeah, all of you, yeah, especially for my students, right? So I see Keegan, I see Lucas, I see Taylor, I see, yeah, I see Rishan, I see Timur, right? So yeah, good luck for you. Good luck for you tomorrow. Have a good rest. Okay, maybe we end here. So if we have if I get the two remaining questions, I will share it with you so you will know about it. Okay? Okay, so now end for the day. End for the day, right? So good luck, everyone. Yeah, good luck, everyone. So hope you get good grade tomorrow in the RMO round 2. Yeah, bye. Yeah. For those who have RMO round 2, just leave as quick as possible. Okay. So meanwhile, yeah, I should edit the questions, right? The handwriting questions into the printed one, which is not that difficult because, right? So yeah, maybe close the stream. Yeah, I think it's okay. So I don't suppose there are new questions.